Okay, so we're going to begin today's lesson with a quick review of our multiplicative properties from yesterday. So right now, on your whiteboards or in your notebook, I want you to take a look at each of these. And, you know, in the essence of time, we may use our whiteboards now. So I will ask you to hold your whiteboards up and let's look at number one together. 1,037 times what will equal 1,037? So on your whiteboards, I want you to put the missing number. What is the missing number? And hold it up when you are ready. What is the missing number? Very nice. I see Julian. I see Sinjin. Lenny. Good. Lucy. Clarissa's got it. Aiden, Mateo, Matthias, Fiona, beautiful. So I'm seeing everybody got it. Yes, the missing number is 1. Who would like to tell me what property that is? Julian?
It's the multiplicative property of 1.
But what's its name? It's not called the multiplicative property of 1. There is a specific name. Does anybody remember what it was? What do we think? Sinjin?
Yeah, identity property.
Identity, right? Because the number that we are multiplying by 1, we get a product that is identical, okay? The next one, 635 times 47 times what equals 0? Quickly, hold up your whiteboards. Just put the missing number. What is the missing number? I'm looking for whiteboards. I see Clarissa had it. Soren's got it. Fiona's got it. Mateo's got it. Aiden, Matthias, Maisie. Thank you, Maisie. You remembered the slide. That's right. It's 0. And I know this one is going to be complicated, but what property is that? Quinn?
Commutative. Oh, wait, no, associative.
Ooh, this one's tricky. What was your product?
0.
So
oh, no, it's
what
0 property.
That's right. In this question, I try to trick you a little bit by putting the parentheses to see if you would know which property it was. Yes, there are parentheses, but we're not changing the grouping, right? We just have 3 factors. So for this one, if we have a product of 0, whenever we have a product of 0, we're using that 0 property. All right. Next one, 75 times what equals 42 times 75? Put just your answer, and you can write it nice and big on your whiteboard and hold up your whiteboard to the screen. And if you know your properties well, you have no solving to do. You shouldn't be sitting there doing any kind of multiplication. Think about your properties and what number has to go there. Okay, nice. Sinjin's got it, Lucy's got it, Julian, Lenny. Waiting for some Fiona, Aiden, Mateo, Soren. Good. All right, guys, so 42. Why? What property is that? What property? Lenny?
The commutative property.
Commutative. What do? We just switched our factors, didn't we? 75 times 42, switch it around. 42 times 75, you're going to get the same product. So we had to use our commutative property. All right, number 4, you don't need to write it out. I just want the missing number. 9 times 6 times 4 equals 9 times 4. What is the missing number? Think of your properties. William's got it. Julian's got it. Lucy, Fiona, Mateo, Soren, good. Matthias, Aiden, Willow's got it. Beautiful. The missing number is 6. 9 times 6. If you read it, it kind of already tells you. It's almost silly, right? 9 times 6 times 4 equals 9 times 6 times 4, right? They're identical. We're just changing the grouping. What property is that when you change the grouping? Not the order, but the grouping. I see Williams posted it up. That's right. It's the associative property. Okay. And the last one, 5 times 20 times 9 equals 5 times 20 times. Everybody can shout it out.
9.
And what property is that? What
9.
property? What property is that?
Associative.
Again, associative. Should you always assume with the associative property that we are just looking for parentheses?
No.
No, why?
No.
Look what happened in number 2. We had a parentheses there, but we weren't using the associative property because as soon as we have to multiply by a factor of 0, all other rules go out the window. Doesn't matter what order I switch it in or what grouping. If I have a 0 there and I'm multiplying by 0, I'm automatically using that 0 property. All right? So I'm going to mute us and let's take a look at today's lesson. All right, so for today's lesson, lesson 2, we're going to be using mental math, okay? And mental math is math that we do in our head, right? All right, so our essential question, that's what the EQ stands for, our essential question or our goal for today is, how can you use mental math to multiply by 10, 100, or 1,000? Okay? I'm going to let you take a look at some of our key terms for today. So we kind of went over this yesterday, but just in case you need a refresher, factors are the numbers that are being multiplied to get a product. So we have a factor times a factor equals a product. The product is the result of two numbers that are multiplied, or the answer in a multiplication problem. And a multiple, you may have heard this before, but maybe not, maybe you didn't remember, is a product of a given whole number and another whole number. So guys, basically a multiple is a times table. So if I said, what are the multiples of 2? You would say, oh, the multiples of 2 are 2, 4, 6, 8, 10, 12, right? The multiples of 5 are 5, 10, 15, 20, 20, right? Those are multiples. Not the same as factors. Factors are what two numbers give you another number. So if I said, what's the factor of 4? What would the factors be? Lenny?
2 and 2.
2 and 2. But what if I said, what are the multiples of 4? What are the multiples of 4? Aiden?
Aren't they like 8, 16?
Yes.
20, 24, 28, 32.
Exactly, exactly. So the multiples would be all of the possible products you would get using 4 as a factor. Whereas the factors are, what numbers do you use to get 4? Does that make sense? The difference between a factor and a multiple, right? Multiples are literally like your times table. You use the number I give you as a factor. Factors are, how did you get that number, right, as a product? All right, awesome sauce. So let's take a look at this question. And I want you to try this on your own. You can try it however you'd like. You can create an equation. You can draw a picture or a diagram. If you have any kind of tools at home or pieces that you want to work with, like manipulatives, you may use that as well. So the problem, suppose 3 people can sit at a table. How many people can sit at 2 tables? How many can sit at 20 tables? When you have your answer, please feel free to hold up your whiteboard, and I'm going to see, I'd love to see how you set up your work. So 3 people can sit at a table. How many can sit at 2? How many can sit at 20? All right. What about, okay. I was looking for the other side, Quinn. Good. Quinn's got it. William's got it. Aiden's got it. Good. Soren, Mateo, Julian's got it. Lucy's got it. Clarissa has it. Matthias. Okay, Maisie's got it. Donovan, we're missing you, buddy. There you go. Maisie had it. Okay, good. So a lot of you got it right away. Let me ask you, did any of you do it in your head? How many of you did it in your head? Most of you did, because even when I looked at your boards, I saw an equation, but I didn't see any steps written out. I saw many of you write 3 times 2 equals 6 and 3 times 20 equals 60. So even though you may have written it out, I saw that a lot of you didn't have any additional steps. So the reason why you were able to solve this mentally is because you've got basic facts in there. All of you know your 3 times table, so you knew 3 times 2 equals 6. And then you said, wait a second, if 3 times 2 equals 6, aren't I doing the same thing? 3 times 20 equals 60. Thank you for sharing. Yes, Sinjin, great work. All right, so this is what most of you did on your whiteboards, right? You realized that 3 people for each of 2 tables, you needed to multiply to get a product of 6. So 3 times 20 people would give you a product of 60. Now, do you notice any pattern here? What if I did 3 times 200 without writing any work out? Could you solve that mentally? What do we think? I see some people already have put it up. Julian, you think we can solve it mentally? Mateo thinks we can solve it mentally. Maisie. Matthias has his answer up. Fiona's already got it solved. Right. This is, wow, Sinjin's got it. Lenny, Willow, Aiden. Yes, so Lucy's got it. Quinn, William. Yeah, guys, this isn't rocket science, right? There is a pattern here. Who would like to tell me what the pattern is between the factors and the products? What do you notice? What do you notice? Clarissa.
So what I do is I take away the zeros and I do like 3 times 2 equals 6, and then I add on the zeros. And if it was like 3 times 20, I do 3 times 2 equals 6 and also add on the 0.
That's correct.
Yeah, and if it was like 2,000, I do the same thing.
Exactly. Exactly. So the pattern is basically you look for your basic facts, and I call them basic because they're facts that you should already have memorized, right? You already know 3 times 2 by heart. You're not sitting there going, right? We know 3 times 2 by heart. And so we find the product of our basic facts. So it's always, in each of these is going to be 3 times 2, 3 times 2, 3 times 2. And then we're going to count our zeros up and add them into our product. So that pattern can be used for any factors that have multiples of 10, 100, or 1,000, meaning we're multiplying by anything that's got those zeros in it. So here are our steps. First, we find the product of the non-zero digits, or as I like to call them, we find our basic facts. In these problems below, our basic facts are the same. 6 times 4, 6 times 4. I'm going to ignore the zeros for now, and I'm just going to focus on multiplying my basic facts. So 6 times 4 is 24. 6 times 4 is 24. Same for both problems. Then I'm going to count the number of zeros in both factors. So in this case, 6 does not have any zeros, but 40 has 1 0. In this case, 60 has a 0 and 40 has a 0. And then what I want to do is I want to make sure that my product has the total amount of zeros. So in this first problem, there's only 1 0 in both of my factors, so I need to make sure my product has 1 0 in it. In this multiplication problem, there are how many? How many? You guys can say it.
2.
2. So you need to make sure your product has
2
zeros. Exactly, right? So that being said, guys, I think it's pretty self-explanatory, right? Now let's try some practice ones, and I'm going to show you how I actually draw this out. So you're following along with me in your textbook. Does everybody have their textbook prepped? And you are going to be on we're on page 66, using mental math to multiply. And hopefully you're able to see my whiteboard really well. I'm going to try and write nice and large. And let's take a look at some practice problems. So we'll start with 4 times 8. And these are our basic facts, right? These are, I'm going to use green today because it's my favorite color. And I like to box my basic facts when I'm solving a problem. So my basic facts are 4 times 8. You guys see the green? Maybe green was a bad choice. What is my final product? And you can shout it out. You can shout it out. Go for it.
32.
32.
32. Lovely. I might switch.
52.
I might switch.
52.
Yes, I might switch colors because even though it's my favorite, it's not showing. So I'm going to use this really pretty teal. Second good color. All right, so those are our basic facts. 4 times 8 is 32. So if I did something as simple as adding zeros into it, and I did 4 times 80. Again, I'm going to box my basic facts, or I'm going to box the times tables that I know. So my times tables are 4 times 8. That's what I'm able to do in my head, yes? So 4 times 8 again is 32, same as up here. Box my basics. I box it in my product also because sometimes when we multiply our basic facts, and I'll try and find an example. Sometimes when we multiply our basic facts, we actually get a product that has a 0 in it. And I don't want you to mix up how many zeros you add onto your product. I'll show you with another sample question. And how many zeros do we have? Let's check both of our factors. Any zeros here? No. Any zeros in our second factor?
Yes.
Yes, how many?
1.
I usually check it off so that I can keep track of my zeros. You don't want to get an answer, and this happens every year, guys. You don't want to get an answer that's wrong for a really simple question like this because you miscounted your zeros. I see it happen every year. So 1 0, I checked it here. I draw it here. 0 0. So my final product is
320.
320. And I'm just gonna check here because I see two people. I see two people entered the waiting room. Give me 1 second. All right. What if I did 400 times 80? Well, I'm going to follow those same guidelines. Box my basic facts. My basic facts are the times tables that I can do mentally. 4 times 8, again. 4 times 8 is, again, 32. Now that I have my basic facts, I'm going to box my product. I don't want to mix it up with the zeros. And count my zeros in both of my factors. So 1, 2, 3. How many zeros are going to be in my product? Eyes are at full power. 3. 1, 2, 3. I need another red marker. Sorry about that. So our final product is 32,000. 32,000. Are we ready to try another one? Does everybody see the pattern? Okay, now I'm going to pick another question that has a basic fact that has zeros in it so that you can see what the method to my madness is. And if you know me and you'll get to know me, I absolutely love color coding all the work that I do. Usually when we're in class, and I'm not sure if you got it with your supplies, but usually when we're in class, I give everybody a box of colored pencils so that they can color code their math notes. It helps you stay organized and it helps you see different procedures and steps and identify them clearly. So you did, I see Mateo's got colored pencils. Awesome. So if you want to color code along with me, I usually use just one color for each step. So one color I'm using for boxing my basic facts and one color I'm using for identifying my zeros. It's not mandatory, but it's a fun way for you to keep your work organized because honestly, every year, you want to know what the biggest error is? Silly mistakes. Every year, the biggest error is silly mistakes. Everyone gets all the tough procedures and then they put the wrong amount of zeros by accident or something simple that could have been avoided. All right, we're going to try one more. Are we all ready? Yeah? Okay, cool. Let me erase. All right, next one. 5 times 20. My first step is to
Box.
box my
Numbers. Factors. Factors.
right. All of them?
No. The ones with the zero.
I'm gonna say it one more time and you're gonna remember it. I'm gonna box my basic facts. Basic. They're basic. Box my basic facts. My basic facts are the times tables that I already know in my head. 5 times
20.
basic.
2.
Timetables. 2. Thank you.
5 times 2.
Thank you. 5 times 2 is
10.
10. Guys, I'm going to put a box around my 10. Do you see how now putting this box, when I have to add any additional zeros, or when I have a lot of zeros, I won't accidentally count this zero as a zero that I've added on because it's in the box. Now I'm going to take another color. Count the zeros. Any zeros in my first factor?
No.
Any zeros in my second factor?
Yes.
Yes.
1 here, 1 here. So
100.
100. Now let's try it.
100.
Let's get 0 happy. Let's get 0 happy. Why not? All right, this is going to be a lot of zeros, guys. I put 3 factors. Dum, dum, dum. I put 3 factors. We're going to do the same steps. Box your basic facts.
No.
5 times 2 is
10.
10 times 5 is
50.
50. Now, let's count our zeros. 1, 2, 3. 1, 2, 3. So my answer is
50,000.
50,000. Does everybody understand how this works?
Yes.
Yep.
Do we get it?
Yep.
Let's try uno más. Uno más. Okay.
1.
What?
All right, I went there. Got a tricky one. 4 times 33 times 25. Ponder, ponder. While you're solving that, does anybody know where if Willow's supposed to be in gold?
Wait.
No? Okay. Well, we'll figure it out.
No, you're supposed
What do we have to do here? What property should I use? Because this is a little confusing to me. I don't know.
Associative.
Yeah, I can't do 4 times 33 or 25 times 33 quickly in my head. And the whole goal for all of this with using our properties is that we can do mental math and we can multiply on the fly without having to do all of these steps and procedures. So when I'm looking here, 4 times 33, I'm going to have to do some sort of multiplication where I'm carrying over and I'm adding, and there's going to be steps. Nah, not for me. 33 times 25, nah, not for me. I can't do that quickly in my head. Do you see any two factors that I could combine quickly in my head without having to do all of these steps? Because I'm lazy. Just
4 times 3 times 5.
Well, I don't want to necessarily split it like that because I'm going to have, it's not really a 3 here, it's a 30.
I think she means the second 3 in 33.
I guess. But then
You
you're
could
still going to
just
have a
do
20 and 30 here.
30 times 20 is
There is something, if you have a really good number sense, there are two factors that go together
4 and 25.
beautifully. Quinn, 4 and 25, who can see it? 4 and 25. I'm just gonna switcheroo something.
Yes.
I'm going to switch my factors around. 4 times 25 times 33. I didn't change any of my factors, so I'm good. I just moved them around. What property is that, Clarissa, when you move them around, the factors all over the place? I switched the order, but
the switching property?
Yes.
That's the property right now?
Yeah.
The switching
Well,
property.
it is. It does have a name. Does anybody know it, Sinjin?
The commutative property.
The commutative property, right. I switched the order. I'm going to get the same product. But now, I can combine these two. 4 times 25 is, everybody?
100.
100. And there is my multiple of 10. Now I just have to do 100 times 33. Watch. What are the basic facts here? Raise your hand. Raise your hand. What are the basic facts, Lucy? That means what can you do in your head?
The basic facts are 1 and 3. But the second
not just 3, it's the 1 times table. What do we know about the 1 times table always?
Oh yeah, 1 times 33.
Yeah, I'm going to do the whole 33 as my basic fact because that's what property again, Willow?
It's the commutative property.
When I have to multiply.
Yes. It's the
I know the names are hard to remember.
Identity.
Yes,
Identity.
thank you. Identity. So why would I pick 3 as my basic fact when I'm multiplying by 1? Why not pick the whole 33, right? 33 times 1 is 33. That's my basic fact, And now all I've got to do is count them zeros and add them on. 1, 2, 1, 2. All right. What is my final product?
3,300.
3,300. Owned it. We got this. Now that took a little bit of work, but that's because I'm writing everything out. Many of you can probably do the 4 times 25 in your head, get the 100, and multiply it by the 33, right? All right, guys, so guys, how are we feeling about this? Guys, thumbs up if you guys are getting this. I see some thumbs up. I'm going to look for the icon. Let me pause my recording.